There's a gap in the light coming back from Pluto, not a shadow, not a glare. A missing piece, a wavelength where the light simply isn't there, as if something on the surface of that frozen world is swallowing it whole. Scientists found it by accident, buried inside infrared data collected across billions of kilometers of empty space. And when they finally isolated it, cleaned it, and checked it against every known substance in the solar system, nothing matched. Not ice, not rock, not any of the organic compounds already cataloged out there. Whatever is absorbing that light at the edge of the solar system has no name, no explanation, and no precedent. Tonight, we're looking at what the James Webb Space Telescope actually found on Pluto, why it took decades of engineering to even notice it was there, and why the scientists studying it are choosing their words with unusual caution. For most of the last 10 years, Pluto has been treated as a finished chapter. In 2015, NASA's New Horizons spacecraft became the only mission in history to fly directly past it, sending back the first close, sharp images humanity had ever seen of its surface. Mountains of water ice, vast plains of frozen nitrogen, a pale blue haze clinging faintly to the edge of its disk. It was a triumph, and it felt like closure. New Horizons flew by in a matter of days, took its photographs, and kept going deeper into the dark, never to return. Once it passed, the door on Pluto seemed to close behind it. For years afterward, nothing reopened that door. Hubble couldn't. Ground telescopes couldn't. Pluto is small, faint, and 4 billion miles away, and every instrument we had was built to see visible light, the same narrow slice of the spectrum your own eyes can detect. Visible light can show you a shape, it can show you a color, it cannot show you what something is actually made of or what it's quietly doing to the light passing through and off of it. To see that, you need an instrument built to read heat itself, to detect the exact wavelengths where different materials absorb light and fingerprints unique to their chemistry. That instrument exists. It's called MIRI, the mid-infrared instrument, riding aboard the James Webb Space Telescope, nearly 1 million miles from Earth. Think about what that gap actually means. For nearly a decade, the most detailed images humanity had of Pluto came from a single flyby lasting a matter of hours. Every textbook, every documentary, every classroom diagram since then was built on that one narrow window. Meanwhile, Pluto kept rotating, kept radiating heat into the void, kept doing whatever it was, doing on its surface, completely unwatched, completely unmeasured, for years at a stretch. We assumed silence meant nothing was happening. It didn't. It only meant nothing was listening. Webb changed that the moment it woke up its mid-infrared instrument and pointed it 4 billion miles into the dark. MIRI wasn't designed to take a pretty picture. It was designed to feel a target's temperature at a distance, to register the faint thermal glow radiating off a surface too cold and too far away for any visible light camera to make sense of. It's the astronomical equivalent of stepping into a pitch-black room and being able to tell, just from the warmth on your skin, exactly where every object is sitting and what it's made of. In May of 2023, Webb pointed MIRI at Pluto and its largest moon, Charon, and recorded something no telescope had ever captured before. A detailed mid-infrared spectrum spanning roughly 5 to 27 micrometers, a range of light completely unexplored on this world until that moment. It wasn't that scientists hadn't wanted to look. No previous instrument had been sensitive enough to pull a signal this faint out of the dark from this distance. What Webb captured wasn't a photograph. It was closer to a chemical confession, a way of listening to what the surface itself was radiating outward as it slowly rotated through daylight and shadow. The results, published in April 2025 in the journal Astronomy and Astrophysics, and again in June 2025 in Nature Astronomy, came from a team led by researchers at the Paris Observatory and CNRS. What they found unsettled even them. Pluto and Charon, two bodies locked together in a permanent gravitational embrace 12,000 miles apart, are not simply neighbors. They are caught in an active exchange. Webb's data confirmed that material is being pulled directly off Pluto's thin atmosphere and deposited onto Charon's. Poles, staining them a deep reddish brown. It is a process that happens nowhere else that we have ever observed. One world is slowly bleeding its atmosphere onto the face of the other, and has been silently for longer than anyone has been watching. That discovery alone rewrote a page of the textbook, but it wasn't the ending. It was only the beginning of what Webb's data was hiding. Because in July of 2026, just days before this video, researchers going back through Webb's infrared archive noticed something they had missed the first time. While studying observations of Saturn's giant moon Titan, an entirely separate world, they found an unexplained dip in the spectrum, a precise wavelength where light was vanishing into whatever coats the surface. They checked it against every known ice, mineral, and organic compound in their reference libraries. Nothing fit. The absorption sat at almost exactly 511 micrometers, and it belonged to no substance human science has ever measured, on Earth or anywhere else. Then, almost as an afterthought, the team went back to the archived Pluto data from 2023, the same dataset that had already revealed the Charon exchange, and checked whether the same gap appeared there too. It did, the exact same wavelength, the exact same signature, present on two of the strangest, most distant, most physically unrelated worlds in the solar system. Titan, a moon of Saturn thick with nitrogen and methane haze, warm enough by comparison to host lakes of liquid hydrocarbons. Pluto, a dwarf planet at the edge of everything, so cold that nitrogen itself freezes into ice underfoot. Nothing connects them. Not size, not orbit, not history, not composition as far as anyone knew. And yet, both are marked by the identical unexplained absorption, as though something invisible had reached across more than 1 billion kilometers of space and left the same fingerprint on each. Researchers moved quickly to rule out the simplest explanation. If the signal came from gas in the atmosphere rather than the ground, it should intensify toward the edge of the disk, where sunlight has to pass through more atmosphere to reach the telescope. On Titan, where the atmosphere is thick enough to test this directly, they compared the center of the disk to its edges. The signal did the opposite of what atmospheric absorption should do. It grew weaker toward the edge, not stronger. Which means, by the team's own analysis, whatever is producing this gap in the light isn't floating above these worlds. It is sitting directly on their surfaces, waiting. So what is it? That's the question nobody studying this data can currently answer. It isn't methane ice, it isn't water ice, it isn't any of the reddish-brown organic tholins, already known to color both worlds. Some researchers have proposed it may be an undiscovered organic compound, something assembled from the same basic chemistry that eventually produces the building. Blocks of life, but arranged in a molecular form never directly detected before. Not in any laboratory on Earth, not on any other body we've ever pointed a telescope at. If that turns out to be true, it means the raw ingredients capable of producing life's chemistry are scattered further and more widely across this solar system than anything we've modeled, sitting quietly on some of the coldest, most forgotten surfaces we have. There's something genuinely uncomfortable about that idea, and it isn't the chemistry itself. It's the fact that this substance, whatever it is, has been sitting on Pluto's surface the entire time humanity studied it, invisible in every image, undetected in every prior measurement, waiting specifically for an instrument sensitive enough to finally notice it was there. We photographed Pluto in 2015 and thought we understood its surface. We were reading the cover of the book and calling it finished. And this is where the story stops being about one small frozen world and starts being about how little we actually know regarding the rest of them. If Pluto and Titan, two bodies with almost nothing in common, are both hiding an identical unidentified compound in plain sight, then the obvious question is uncomfortable to sit with. What else is out there, coded in something we don't have a name for, simply because we've never looked at it with an instrument capable of noticing? Every icy moon in the outer solar system, every distant Kuiper Belt object, every world we've only ever photographed once in visible light and filed away as understood, could be sitting under the exact same blind spot Pluto was hiding under for the last decade. We don't know, because until Webb, we never had the ability to ask. That uncertainty is precisely what has researchers choosing their language carefully in the published analysis. Nobody studying this data is willing to claim they know what the compound is. They are only willing to say, cautiously, in the dry, measured language of peer review, that it does not match anything currently known, and that its presence on two unrelated worlds separated by more than 1 billion kilometers is not something their existing models predicted or can yet explain. There's a reason nothing found this before Webb. Every earlier infrared instrument on every earlier mission lacked the combination of sensitivity and spectral range required to isolate a signal this faint at a wavelength this specific, especially from a target this distant and this dim. It took a telescope shielded behind a 5-layer sunshield the size of a tennis court, cooled to within a few degrees of absolute zero, sitting nearly 1 million miles from every source of heat and light on Earth, to finally be quiet. Enough to hear something this faint at all. For decades, the signature was there. It was simply louder than anything capable of detecting it. NASA's next real chance to identify it is already on the calendar. The Dragonfly mission, a rotorcraft lander built to fly directly across Titan's dunes and lake beds and sample its surface chemistry firsthand, is scheduled to launch later this decade. Researchers are hoping its direct measurements might finally put a name to the molecule behind the 5.11 micrometer signal, and by extension, explain what's coding Pluto's surface as well, 4 billion miles further out, where no lander has ever been sent and none is currently planned to go. Until then, the signal simply sits there, unclaimed and unexplained, written into the light of two worlds that have nothing in common except the fact that both are hiding the same secret from us, and both have been for as long as we've had the means to look. No lander is scheduled to touch Pluto's surface in our lifetime. No follow-up mission currently exists to confirm what Dragonfly might eventually find at Titan applies out there as well. For now, the only tool capable of studying this mystery at all is the same one that found it, still orbiting a million miles from home, still listening. What Webb has shown us is that Pluto was never actually finished business. It was a world we photographed once, quickly, in visible light, and mistook for fully understood. Infrared light told an entirely different story, written not in color, but in heat, in the precise way a surface holds and releases energy, and it turns out that story still has blank pages we didn't know existed. Somewhere in that 5 micrometer gap in the spectrum is a substance with no name, sitting on the frozen ground of a world we stopped paying attention to a decade ago. And whatever it eventually turns out to be, it already proves something we should sit with. The outer solar system isn't the quiet, dead archive we assumed it was. It is still hiding chemistry we cannot identify, processes we cannot explain, and signals that were there in the data all along, waiting patiently for someone to finally notice them. If you want to be here when scientists finally put a name to whatever this is, subscribe and turn on notifications, because this story is not finished, and the next signal to come back from 4 billion miles away might be even harder to explain than this one.